This is section 1.3, rates of change and behavior of graphs. We're going to start out by talking about average rate of change. So if you remember back in Algebra 1, rate of change is just another way of saying slope. So what we're doing is we're calculating slope between 2 points. So the change in output over the change in input, or the change in y over the change in x. So we want to find the average rate of change of the price of gas between 2007 and 2009. The table gives us a bunch of different points, but we only need 2 for slope. We got to figure out which 2, which luckily the words tell us that we're using 2007 and 2009. So let's set it up. Output minus output over input minus input. So we get negative 0.89 over 2, which is negative 0.445. So a number answer is great, but we want to interpret that since it's a word problem. We're finding the average rate of change of the price of gas. Okay, the negative is telling me that it's decreasing, so it's down about 44.5 cents per year. So that means gas is changing on average between those 2 years. It's going down 44.5 cents per year. All right, let's find the average rate of change on the interval from -1 to 2. Okay, so we're using -1, got to find the point, which is right here. And 2, find the point, which is right here. So we're finding the slope between those 2 points. You can go back to Algebra 1 and count if you want, but I'm just going to set it up for you. So y2 is 1 minus y1 is 4 over x2, which is 2, minus x1, which is -1. So we get -3 over 3, which gives us -1. So our average rate of change is -1. Slope is -1. Now we're going to talk about behavior. So we're going to talk about increasing, decreasing, and constant. So increasing, we're going to read graphs just like we read books. We're going to go from left to right. Increasing means the y values are growing. Decreasing means the y values are going down, So we got to talk about where it's increasing, where it's decreasing. Sometimes it's helpful to figure out where it switches from one to the other. Draw a vertical line. Same thing here. And then we're going to use interval notation. So in this case, we are increasing. Okay, I see this interval is increasing, and this interval is increasing. So let's start with the left one. It's increasing from -infinity to -2. Okay, we're going to make that not included. This U means union or and, from +2 to infinity. It's decreasing in the middle here. So it's decreasing from -2 to 2. We don't include it because technically at -2 and 2, it's constant. It's switching, so we don't include them. And if it's constant, remember that's just going to look, if here's our x and our y, it's just going to be flat. That's what a constant would look like. We have local and absolute extrema. Extrema are maximums and minimums. Local means it's in that area. It's either the highest or the lowest point in that area. An absolute means it's the highest or the lowest in the entire graph. So if we look back here, we've got a maximum here and a minimum here. those are both local because the graph is going to continue on it forever and ever in both directions. So it does get higher than this point, and it does get lower than this point, so it's not absolute. That would be local. So state intervals of increase and decrease, and then find all extrema. All right, I'm going to draw my vertical lines where I have maximums and minimums. That just helps me find the x values a little bit easier. So increasing, let's find out where it's increasing. Well, it looks in this side, well, then it's going down, and then it's going up, and then it's going down. So we're increasing from, it looks about to be negative 2.5 to negative 2. And so union from 0 to 2. It looks to be decreasing here and here. So it's decreasing from negative 2 to 0 and from 2 to 3. When we look for maximums and minimums, okay, the endpoints do count for that. So it looks like I have one here, 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 and here. So we have both absolute and local. So let's start with local. We have a local max at x equals negative 2. Actually, that's an absolute, sorry. Absolute. And since it's tied with the one at 2, it's also at x equals 2. We have a local min at x equals 0. And we don't have any local maximums, but we have an absolute minimum at x equals 3.